Hello everyone, this is a quick presentation on the subject that we were assigned to for class, and I want to go over the presentation really quickly. Hopefully it will be over less than 5 minutes. There's a lot of information out there, but we see that people will use whatever they have for unmeritorious activity. So based on that, we thought we would create a software program that would help one avoid the unmeritorious activity, whether that be an accident or something intentional, like being a good driver. If one knows how to be a good driver, hopefully they will also be good all the time. So, of course, there's lots of statistics there. Of course, the U.S. is a very unique place, and we decided that we can't really compare it to other countries because, well, it's a unique place with a unique history. It's not comparable to what used to be a monarchy or more of a totalitarian type of society historically. There have been problems in the U.S., but not like the other countries, and so it's really hard to do a comparison, especially since the U.S. is also very diverse too, and people love to come here. So it's really hard to say whether there's, quote, a problem or not, but we can do our best to reduce any trouble through education. The program that we made hopefully will reduce all of these unmeritorious activities here, and we hope it will reduce it drastically. And then also, this software program can be available in on many different platforms, so people can probably use it on their smartphone. So everyone should be able to benefit. Getting more statistics, we see that America is a very diverse place, so it's very hard to come up with a one-size-fits-all type of solution. So therefore, safety training and education probably is the way to go, and that's what we made here. Again, there are lots of groups who do different kinds of statistics. A simple count of a statistic doesn't really work very well because some cities have more people than others. So some of the better statistics are where they have more of a proportion going on, like a per capita type of number. Again, we're hoping that this program will reduce all of these incidents, but it should be especially good for the unintentional ones, where there's an accident of some sort. Oh, surprise, it actually worked. Oh, I don't know what happened. Things like that. Again, it was hard to correlate based on these. America's a very unique place. People have the money to actually buy these tools, but in the countries where they don't have the money, there's also a high suicide rate. A high homicide rate. So basically, our conclusion there was that people will use whatever they have to commit an unmeritorious activity if they choose to do so. Therefore, these results that was the only conclusion we could come up with. Again, other countries have very different types of laws. The United States, again, is a unique country because, well, our Constitution really prevents laws for firearms, and there's a reason for that historically. Again, kind of another place it's hard to compare it to other countries because other countries are very unique, and again, their citizens want to come here, so they must like something about this place. So. Again, more statistics of incidents in America would be great to reduce these. And so there's, I guess, proposals for that, but we think firearm safety possibly could reduce these really rare incidents. So what can you do? Well, in this case, we thought we would provide a software program that would be fun and educational for everyone, and really wouldn't be controversial at all. Everybody loves a good education, and this is really just education about how to operate a machine, in this case a firearm, not about what people think it is or what you should do with it. It's more like, is it more basic safety principles. And so, it's controversial in some parts of America, and there's many statistics, but we thought we could just get around the controversy by going for education and proper use of this machine instead. And again, we have again plenty of statistics, but at the end of the day, controversy aside, the person holding such a machine, such a firearm, will determine the outcome of the situation. So let's get into the code. But first, let's look at an overview. So in the documentation that I wrote, just a quick page, these are all the classes for the program. The ones in yellow have not been completed yet due to time constraints. There are some parts of the code that required many hours of research, and for a beginner in Java or programming in general, that took longer than it would for other people. But the classes in white are almost ready, and we'll see some functionality in here, and we'll see what structures and techniques were used. The ones in yellow are not created yet. The class called Executor, I just called that the class where if you run that, the whole program runs. It pulls up a welcome screen that tells the user Jeff Cooper's 4 rules of firearms. The idea is that any violation of those 4 rules will result in something wrong happening. So as long as the user follows the rules and the logic, and which is wonderful for a software program, then everything should be fine, and thus good outcomes for our users. The program generates scenarios. These scenarios will take elements that a user or instructor can put into an array, and then the program will randomly choose the appropriate array that has the information relevant to the scenario. The end result is that all the elements in these arrays, inputted by the instructor, for example, will produce many unique scenarios that the user can practice with. And as a result of their practice, their score, based on their performance in the scenario, will be put into a report. And that report, again, not done yet, will be a class, a superclass, and then the report, the user will get a report telling them whether they passed or failed the scenario, or scenarios will be given to them. Of course, the superclass of report will give them things like their name and things like that. But in the subclass, things that will be unique to the subclass of that would be telling them whether they failed, maybe putting their showing their score in a different way. But that would basically be the structure. Again, not implemented. Only the white classes here are implemented, and we believe this is a success so far, because we think the hard part's out of the way. We've got the structure down. We've got the random number generation, and I'll show you in the code where I hit a roadblock there. But once that roadblock is clear, we think this is the rest of it's just very easy to do. So here we go into the code almost. Hold on, here's the classes. And then once we go into the code, you'll see there's different arrays here. These arrays will create the scenario. Some scenarios will use the materials array, and materials means whether if the gun is pointed at a safe material or an unsafe material, whether there's going to be movement in the scenario. So the scenario generator will randomly pick number 1, for example, what the relevant arrays are. Let's say it only picks the materials array. Then it knows that there's 2 more arrays associated with that, named materials safe and materials unsafe. It manually picks one of them, and the result of that is whatever array is picked, that means the scenario is going to be safe or unsafe. So in this case, if it picks the safe array, it's going to create a scenario that's safe. For example, the user is pointing the gun at the ground, and that's safe. So then the user would be presented with that scenario, give a yes or no as to whether it's safe, and then the result would be shown by the program whether they got it right, and then they could move on to the next scenario. Um, we think this is a good program because it's scalable, and you'll see that here in the code. So then here, let's go into the main function here, the executor. Okay, and so far it's pretty simple. What it does is it brings up a class called the welcome class, and it just displays a welcome message as well as educates the user as to the rules of safe handling of firearms. Then it opens it runs the scenario generator class where all the work really happens. In this case, first it does two activities. One is it generates the arrays in the scenario. We'll see what that looks like. And the next thing is that it starts a scenario. So again, generating the arrays is basically syncing up what would be basically like a database, or syncing up the information. Well, we'll take a closer look here. It's complicated. So let's run back to our diagram here. Again, the main program, main class, executor, goes to welcome. So now let's get into the scenario generator. And actually, let's look at this. What happens here if we run it? So again, it's not complete, but basically the user is told, okay, here's how you safely handle a firearm. The rest of this here is just debugging information. In this case, well, we'll get into that later. But here the user is given a scenario, and we can make thousands of these. We only had time, since the program's not done yet. We only had time to just make one scenario. But once it's done, we can really get in there and scale this up. So in this case, they get the scenario, and I put a little colon here saying, here's the decision keyword coming up. It picked from an array and picked the word sky. Well, the rifle is pointing toward the sky. That's safe. I say it's safe. Now, of course, our program doesn't work yet, so it's going to tell me I'm wrong. But I need about another hour of work to get that right. But if I do that, we should be fine. So we're on the right track, and I'm going to explain all the logic and everything, but I think we're looking good based on the time we had. So let's get into the more complicated code here. So just based on what we're importing here into Java, it kind of tells us what it's all about. We're using array lists, and that's contained in those array lists are strings that the instructor could input in there to make new scenarios with. Of course, we chose array lists because they're scalable arrays and thus don't have to be recreated every time you add something to it, unless you make a really big array. But we thought array lists would be more efficient, and if computation ever becomes an issue, then we could just use regular arrays, which are much easier to, much faster to compute. We use the collections thing here in Java. So that the whole purpose of this is to, and one of the reasons we use array lists in the first place is to make the code really clean. So basically, to create an array, to put all of this information into an array, instead of let's say this is has 1,000 elements in it. Well, that would be 1,000 lines of code, for what we usually use in class. Element.add, array name, just things like that. It's just too much. So this enables us to have an element that is like to create an array that has 1,000 elements in it, 10,000 elements in it, let's say, and just create the array with one line. For example, the materials safe array, we just initialize the array, we create the array, we create a list of everything that we want in the array, and then we run a command that imports everything from that list, from that array list, into the array. So basically in 3 lines we've populated an array that could have, you know, 1,000 elements in it. So scalability was kind of a nice thing in case instructors and schools want to start using this. Again, the sources were very helpful, especially with how to get everything into an array, get an infinite amount of elements into an array in 3 lines using collections, finding out how to use random numbers, which is covered in the course, but this helped. Part of picking a random element in the array requires finding how long the array is. In this case, we're using array lists, which I believe is outside the course material, so that helped. And then also the hard one, which is comparing arrays. Not covered in the class, but very important for what we think will be this program should be used for in the future. So here's how the class starts, and let me just scroll down. So there's the class, and the class has these methods. A method for generating the arrays, a method for the scenario. So each scenario would be a class. Yeah, if the person's in a castle, that's a scenario. If they're on a boat, that's a different scenario. So this instructor could maybe add scenarios through a graphical user interface of some sort that would create these classes. And then another class we have in the program as it is the a class that picks random elements from an array. So that's what makes our program unique, is that it can create random scenarios, which enables uniqueness, which enables fun and games and repetition and all that good stuff to solve our problem that we were presented with. So I had to put the array lists and the strings for them here in the highest level of the class. I tried to put it inside the method, but it didn't work out. So, but I could keep the collections here inside the generate arrays method. Again, generates the arrays from a list of elements, and one of the things is that at the end of the scenario it asks the user, is this safe? Made a variable for that. Of course, there's going to be user input in there too. So the scenario begins, and I'd say most of the code in here should be moved to its own class. Given time, we'd do that, so that each scenario hopefully would only be about maybe 5 or 6 lines of code. We basically crammed all kinds of decision making and logic here into one scenario. But again, if we solve the problem that we ran into, we would make it much shorter. So when the scenario begins, the scenario generates its own array. In the scenario, there is a list of, a string, that array string, that has a list of everything that's relevant to the scenario. In this case, in this scenario, we're only going to be using an array that pertains to safe materials. So just 2 arrays, and the other scenes might use 10 or 12, who knows. And just like above, with doing all the importation, it's the same way too. Now here's the computer science-y part about it. When the scenario starts, as you saw here in the debugging, it will compare the contents in this array with the contents in that global array. So in this case, there's an array called scenario safe materials. All the materials that are safe to have in the scenario are here. And then there's another global array that could be massive that also has materials. And some of these materials match what's in the scene. So what this does is it enables an instructor to import thousands of terms into a global array or list, and then drag and drop those in a GUI, for example, into, or basically drag and drop those into a scenario. So there could be an interface that just, user can pull up those keywords, drag and drop them into a scenario. And so when the scenario starts, it'll compare the keywords it has in its scenario with the global array list. And there's good reasons for that, to make sure that everything in here is legitimate. Number one. Number two, just to really just do let's say we can even do a synchronization feature after this of some sort. So this makes it more scalable. Now there is a performance issue in here, I noticed. We do have an ON squared operation here. And so if it's a massive array, let's say this is like 10,000, has 10,000 elements, it's going to take forever. It's going to compare all 10,000 elements to this little tiny array here. That's not good. So to save time, what I could do is swap these two arrays here. Instead, just compare this little tiny array to the big array, and hopefully it'll find all the matches early enough, and therefore it will definitely take less time. And hopefully, maybe it might be sorted in some way that maybe it will find all the matches quickly. So anyway, there's our computer science-y performance type of explanation. Again, here and here you have ON squared. By changing the order of iteration, we can save a lot of time if this program scales up. Now on to the random part. So when the next thing the scenario does is it needs to determine which array am I going to use. Am I going to use the array of safe things or unsafe things? Of course, if I use the array of safe things, the scenario will be safe, and the user should answer, yes, this is a safe scenario. And so what we do is we take the list of relevant arrays, is it safe or unsafe? In this case, there's only 2 relevant arrays, and feed that integer of 2. We count how many elements are in the array. We see 2. Okay, feed that value into the randomizer class, get your random number, and that random number determines which array I should use. If I get back a 0, then it will choose this array. If I get back a 1, it'll choose that array. So we've randomly chosen which array we're going to use, and the array determines whether the scenario is safe, which determines whether the user should answer yes or no. So there's the randomness. Major problem that came up here is that once this array is chosen by the randomizer, I could not figure out how to open this array as a variable. So let's say it chooses this array here, and then I'll feed it into, I think I might have commented it out by now, but basically inside, this is the name of the array I want the program to open, and inside that array it has all these materials that can be randomly chosen to be put here in the scenario. Of course, I just kind of forced the scenario to say something. I said, okay, well, just pick 0. We can't do the random numbers because I can't figure out how to export the elements into, get the variables, get the elements of the array called by a variable or a reference of some sort here. So that's the big problem. And so as a result of that, I couldn't call random elements. I couldn't put random elements into the scenario because I couldn't solve that. And also, that also kind of messed up the logic in some other places too. Of course, this logic will need some help here too, but if the user answers correctly, their score gets increased. And if they don't answer correctly, well, they're told they were incorrect and they get told their score, which hasn't changed. So that's really how far we got here. Again, just that one issue I talked about there is what prevented us from finishing the program. Probably would have, would have saved us maybe 7 hours, and so in that case, it would have been finished. But as you can see, again, we've done some interesting things kind of outside the material of the class. We imported content into an array in mass, and we did an n-squared search through arrays to basically compare arrays. This can also be used in the future for creating new arrays. Ideally, what I wanted to do was take these two arrays and create a new array, and then based on the commonalities of these arrays, that would be what would be put into the scene. So there's a lot of potential there. So I believe this sums up what we've done with the program here, and thank you very much for listening.